More probability distribution function questions. 1. The probability distribution of a discrete random variable u is defined by the probability of big U equals little u, which equals k brackets u minus 3 brackets 8 minus u when u belongs to the set of values 4, 5, 6, 7. A. Find the value of k and hence draw the table of the probability distribution of u. The probability that u equals 4 is equal to k times 4 minus 3 times 8 minus 4, which equals 4k. The probability that u equals 5 is equal to k times 5 minus 3 times 8 minus 5, which equals 6k. The probability that u equals 6 is equal to k times 6 minus 3 times 8 minus 6, which equals 6k. The probability that u equals 7 is equal to k times 7 minus 3 times 8 minus 7, which equals 4k. The probabilities added together must equal 1. Therefore, 4k plus 6k plus 6k plus 4k equals 1. Therefore, 20k equals 1. Therefore, k equals 1 over 20. Therefore, the table of probability distribution of u will look like B. In 100 trials, calculate the expected value of each outcome of u. In 100 outcomes, the number of 4s is equal to 1/5 times 100, which equals 20. The number of 5s is equal to 3/10 times 100, which equals 30. The number of 6s is equal to 3 out of 10 times 100, which equals 30. The number of 7s is equal to 1/5 times 100, which equals 20. C. Find the mean value of u for the 100 trials. That would be equal to 20 times 4 plus 30 times 5 plus 30 times 6 plus 20 times 7, all divided by 100, which equals 550 divided by 100, which equals 5.5. D. Interpret your answer. 5.5 is the middle value of the distribution. Expected value. The expected value is also the mean of a discrete random variable x. So mu equals e of x, which equals the sum of x times the probability of x. The mean of a random variable may be interpreted as the average of the values assumed by the random variable in repeated trials of the experiment. Example 1. Let's take the probability distribution function for a fair dice and work out the expected value. The expected value of x is equal to the sum of x times the probability of x, which equals 1 times a sixth plus 2 times a sixth plus 3 times a sixth plus 4 times a sixth plus 5 times a sixth plus 6 times a sixth, which equals 21 sixths, which equals 3.5. That means that if a dice is rolled many times, the average score you would obtain on that dice would be 3.5. Example 2. Find the mean of the discrete random variable x, whose probability distribution is described in the following table. The mean mu is equal to the expected value of x, which is equal to the sum of x times the probability of x, which equals minus 2 times 0.21 plus 1 times 0.34 plus 2 times 0.24 plus 3 times 0.21, which equals minus 0.42 plus 0.34 plus 0.48 plus 0.735, which equals 1.135. So the mean value is 1.135. Example 3. A service organisation in a large town organises a raffle each month. 1,000 raffle tickets are sold at $1 each. Each has an equal chance of winning. First prize is $300, second prize is $200, and third prize is $100. Let X denote the net gain from the purchase of one ticket. A. Construct the probability distribution of X. B. Find the probability of winning any money in the purchase of one ticket. C. Find the expected value of X and interpret its meaning. There are two ways to attempt this problem. The first way takes in the price of the ticket at the end. The second way takes in the price of the ticket at the beginning of the problem. There are two ways to attempt this problem. The first way is to take into account the price of the ticket at the end of the problem. This generally gives easier calculations. The second way is to take into account the price of the ticket at the beginning of the problem. Way 1, the price of the ticket at the end. In this way, you have 4 possible outcomes. You win nothing, you win first prize $300, you win second prize $200, or you win third prize $100. The probability of winning nothing is 997 out of 1,000. The probability of winning the first prize is 1 out of 1,000. The probability of winning the second prize is 1 out of 1,000. The probability of winning the third prize is also 1 out of 1,000. So B, the probability of winning is 3 out of 1,000. There are 3 ways to win. You win first prize, second prize, or third prize. C, therefore the expected value is equal to 0 times 997 over 1,000 plus 300 times 1 over 1,000 plus 200 times 1 over 1,000 plus 100 times 1 over 1,000, which equals 600 over 1,000, which equals 0.6. Now we need to subtract the price of the ticket, $1. Therefore, 0.6 minus the $1, the price of the ticket, gives an expected value of minus $0.4. This means that you would expect to lose $0.4 every time you play this game or buy a ticket. Way 2. Price of the ticket at the beginning. Doing it this way, the value of X takes 4 different values. If you don't win, it is the same as losing $1. If you win first prize, you actually win $299. If you win second prize, you actually win $199. If you win third prize, you actually win $99. These are the prizes after you have removed the price of the ticket. B. Again, the probability of winning is 3 out of 1,000. In this case, the expected value is equal to minus 1 times 997 over 1,000 plus 299 times 1 over 1,000 plus 199 times 1 over 1,000 plus 99 times 1 over 1,000, which equals minus 997 over 1,000 plus 299 over 1,000 plus 199 over 1,000 plus 99 over 1,000, which equals minus 400 over 1,000, which equals minus 0.4. Again, the expected value is minus 0.4, which means every time you play this game, you will lose $0.4.